in. Welcome back. This is the fourth video of the video series that I'm making about building OpenAPI clients. And yeah, this is already the fourth video, but it feels like I haven't made a lot of progress. So I'll just keep making them until I have something I can show off and I could actually use with a nice schema. So let's see how that's going. Okay, looks like looks like it's working. I can't tell if the bitrate has stabilized or not, but I guess we could get going. It will take a couple of minutes to recap what I did the last time, which is basically making or adding enum members. So for enum types that we're generating, we've also added a format function which is able to return a string from the added enum value. Let me just show you how that looked like. I also made a couple of changes, couple of small changes off screen, mainly that has to do with updating FSAST and updating the recent Nougat. I'll show you in a bit. Okay, so these are the enums, and this format function is an instance function where it returns a string that was also inside of the compiled name without us having to do that. So that's quite nice. That's a little bit of an intro into adding an instance member. It was also quite annoying because you have to create all these clauses per value. So for each value we create a match clause, and from a match clause we create a match expression, which is this entire thing. So yeah, these could be a bit annoying. What I did when updating the Nougat package is that I updated the record creation parts. So these are now functions in the API. So instead of just the string double, these are now the API. GUID is added to the API. Array, I think it was added, but I'm not sure. It should be. I thought I added it. Maybe because it's an input, because an extension function called array, it conflicts with the array case of the type. Okay. Well, this works too. It's an array of bytes. And of course we have enums, and yeah, so a little bit of changes. Also, when referencing a type, just make sure that we all can use the title from the schema if it exists. Otherwise, use the name of the reference, the ID of the reference, excuse me, because sometimes that they provide the title, and if they provide the title, then that should be used because that's more like the usable class name or type name from the client side of things. All right, everything looks good. Okay, what I want to do today, oh yeah, one more thing I added is the ability to read this local file. Let me just, it's a bit too much. Yeah, so I added the ability to read a schema from a local file, and this is also what's happening in here, because the main function is just this, where GetSchema takes a schema from this file, and yeah, it resolves everything. It creates the global types and it outputs the types here below. So that works quite nicely, and I added this in here so that I could make changes in here and I can see the results reflected here below. So another example is not in the paths, not in the security definitions, in the definitions here, I have a category that has a title which overrides the category type name. So now pet has a category of optional type of category, and the category itself will also use the title instead of using the type name here, because title overrides whatever is in here. It's a choice. Maybe later it can be a configured option. for now I like this thing. One more thing I want to try to fix today, well, this is the main thing I want to try to fix today, is nested types. Because right now when we encounter a property which is of type object, we don't know what to do with it. So here nested becomes an option of a string. So I want to look into how to solve this, and then we can start looking at the paths. We can start looking at the paths here and start making the client, the HTTP client, which will be quite a challenge of itself, especially because of the parameters, and each parameter has to go in different place. One goes into the path, one goes into the query, one goes into other places, etc, etc. Okay, so far so good. Of course, like always, I'll be looking at the chat. If you have any questions, just let me know. You could always watch this again on YouTube, because after each stream I'm recording. So after each stream, I will take the recording and publish it on YouTube. You can find it on the How I playlist in F# if you just look for it. I will send you a link if you're interested. Okay, so yeah, this is kind of what we have on the table for today. I want to try to fix it quickly so that we get to the good stuff. So let's look again at how this worked. So we start looking at this the top level types. Let me just call them top level type, because these are always the object, or top level objects, because these are usually what the top level schemas are. And value title. So here we're using either the key or the title, and here as well. And here checking only if the type is an object. There is the possibility that the top level object is an enum. I'm not sure if we have accounted for that. Let me try that real quick. So if I don't have not a pet, not a tag, let's say user role, and user role will have type let's say string, and it will be enum. Enum will be a list of admin or user, admin or user, something like this. So these are user roles. Let's see how this looks like. Because I'm pretty sure we should be able to reference user role in somewhere else. So I see that we are not looking into it, and that is because we are not looking at the top level object. So if we can check if it's an enum, and we already have logic to do that somewhere else. Yeah, we have this predicate to check that something is an enum, and we have it again one more time when we're doing this. No, when we're doing this. So I'm thinking maybe it's better if we maybe it's better if we did a simple pattern match. Let's make an active pattern for this. So let's say enum, string enum, which will take a schema, and will return us something. So if if not is null and this thing occurs, then what we want, then we do something, namely we will figure out what the enum cases are, which we already do here. So this is how we figure out the enum cases. Format it a little bit. And cases will be a sequence of string when every type of enum is this string. Okay, so if we have cases, if not sequence is empty of the cases, then we have a string enum on our hand, so that will be some cases. It's not property schema, it's a schema, else none, else also none. Does that work? Yeah. So it's an active pattern that returns me these things. Let's say sequence to list, because we don't like those. Yeah, now we have an active pattern in our hand that we can use whenever we want to check whether a schema is a string enum with a bunch of cases. So in this case, we cannot check it here, I think, unless we use it here. So what I'm just gonna do is I'm just gonna go like this. String well, maybe I don't need to do it here. I need to do it where I actually need the cases, which is down below. Yeah, something like this. Well, I could even do it here, right? So match schema with, so match schema with string enum of cases, and that becomes enum name and the cases. Otherwise, we do this. Does that make sense? So if the schema is a string enum that has a bunch of cases, then enum name. Otherwise, you have a. Otherwise, if it's an object, right? If the schema is an object, then we look into the properties. I think that that makes more sense like this, to recursively search the schema. Actually, we need the actual enum name if it has an enum name. So when enum name has value, okay, is some, then enum name value, like this. So when enum has a name, and the enum cases are those. Okay, I think that looks much nicer like this. Okay, let's do the same for the top level objects. Else And if the type is a string, then match the top level object with a string enum of cases, in which case we want to create the enum, right? And we all have a create enum type function, which should take the enum name, which will be the type name. Or maybe I could do it, I could take the type name here. So I could use it for the object and for the enum. Okay, if the top level type is object, then we create record from it. However, if it's type string with an enum, with enum cases, then we create an enum from it. So if it's enum top level value, then create enum type, where the name will be the type name and the cases. If it's not, then we don't do anything else. We don't do anything. Okay, so this I think handles the user roles now. If object, create record. If top level value is string and it's an enum, is a string enum, then create an enum type from it. Both create enum type and create record from schema return the same type, which is syn module declaration. And here we have it. We have user role. User role is compiled into this thing. So that's quite nice. That's quite nice when it comes to the global types and the top, at least the top level types. So now let me go to user, add another property that is the user role. So that will be role, and role will be, I think, like this. Definition user role. It's possible to do it like this, so I'm gonna run, see how that goes. Hi Dimitri, how's it going? As you can see, I'm deep into this thing. Hey, there you go. Role is now option of user role, so that's cool. We're now able to take the top level enum types. Okay, that's one. But what happens when I have a nested object? And now back to the original problem. So that's the problem solved here. What about the original problem where I had nested objects, which is really the annoying part here? So if I look at so nested objects occur when you are iterating through the properties of an object, and then suddenly one of the properties has the type object, which is annoying because I need to do stuff recursively. So let me see how I am doing that when I'm creating record. I just call it, well, yeah, it's just a record from the schema. It creates a record for each property. We are taking the field, creating the field type. Let me just break it down. So field type is this, and that's the field type. And we're creating the docs, and then we're creating the field. So here we will say, if this is something that we already know how to handle, which is everything except value type is not an object. So if this is something we know how to handle, then do this. Otherwise, do something else. I think I have to yield and then implicit yield. Yeah, there you go. So if it is not an object, then I know how to handle it and I create a proper field from it. But otherwise, I need to do something else. And what I need to do, I feel like, is that I need to call getRecord from schema again. But this returns a syn module declaration. And it doesn't return something that I can use. All right, let's see. Record representation. I'm quite busy lately. Nice to see your progress. Thank you. Use your advice doing a migration to Fable 3. So far, so good. Thanks for the tip. That's great. No problem. Happy that's working for you. What are you building? Are you building some side project or production app? In the meantime, let's see how this goes. So let's make this recursive. And since it's recursive, well, it's not just because recursive, I'll return a list of types. So I won't return one simple type. I will return a bunch of them. Because when creating a type which has an object which has nested objects, I might need to output multiple types, I think. So let's see how this goes. Or do I? I'm not sure. It is recursive now. Let generated, let nested field, or nested object, so to speak. So if we have a nested object, then we create a record of which the name will be a combination from the current record name plus the property. So the next record name will be something like the property name, which will be the record name, plus capitalize the property key, and the object will be just the property value. Production app. Oh, cool. Nice. Okay, so this is a bit of the problem. What I get here, what I'm trying to compute in this part is a bunch of fields, record fields. But suddenly, one of the fields has to be a nested object, which is a module declaration. And I can't do anything about module declarations in here. So that's annoying. Well, what I can do, and this is not something I am very proud of, but let me try it. So, nested objects. I'll keep track of the nested objects here and return them here. Nested objects will be a list of syn module declaration. So once I've had them here, I will add them. Add this nested object and create a field here. I think I could put this right here so that I could reuse those properties. All right. If it's not an object, then it's probably primitive or a union, which is also primitive. Otherwise, it's a nested object, and create it. Add it to the list of nested objects that we created above. Then check for optionalness, I guess. So if, and create another field, of course. So we need another field here. Let's create the field type. So let field type will be, if required, then syn type option of the name of the generated type, which is something that we will have to come up with. So, well, it's actually this one. Nested object name, nested object type name, the generated type for our ad hoc nested type. You see, this is the problem that I'm getting from OpenAPI documents, is that they could have loose types. So you could have just a random nested object somewhere. And what I want to do is I want to create actual types from them. And the reason has to do not just with making the schema correct, but also because serialization works best when everything is a record, when we're talking in Fable and in F#. So all this effort here should be worth it when we look at serialization, and everything will magically work because we have records. Okay, that's quite the claim, so let's hope it works. So if required, then syn type create, I think I can just create one from the type name. Else, if it's required, else then it's syn type option of whatever I created above. So that's the field type. The field name is still the property name, of course. So let me create the field like this. The docs and the field are still the same. Okay, and now we have, once we create our type, we say yield the nested type first. Yield the nested objects, and then yield the other syn module. What's happening here? What's wrong? I cannot just yield this. Okay. For nested object in do yield nested object. What's wrong here? I have a syn module declaration. Wait, what if I have this? Yeah, I think IntelliSense is saying later in the program you're not using this as a list. So why is it here a list? So it's a good time for to create a proper public type. Yeah. So the failure should go down below. Yeah, and this one also returns a list of those, so I should add range here because the recursive call might return more objects. And here I will just say yield nested objects. Oh, thank you. So this works. That's cool. I think it works. It looks like it will, but I'm not sure. If this works, I'm happy. That would be really cool. And of course here we need to yield those because we get a bunch of them. We get a bunch of them, and we have to yield all of them. Okay, I think this is going well. Maybe too well. Hi all, offside rule. Ah, that, yeah. Hi Gareth. How are you doing? Let's see. Nested has the type pet nested, okay, and pet nested is right here, which has an ID of int64 and a name of pet category as well. Pet category should not be outputted as part of the nested object because it's using a reference type, and that is handled from the record. I'm doing very well, thank you. Have you been streaming lately? I used to watch your streams. Have you been streaming F# stuff? Let's see. If it's not, or not is null. Oh, the reference is not null. So we talked about the references. So if I have a non-object or I have a reference type, create the fields. But otherwise create those nested types, okay? Not much, and moving to more games and Rusty's games. Ah, Rust sounds cool. I heard it looks a lot like F#. I've been looking into trying it out. But for me, maybe it's just a little bit low level, you know? Because it's all about the security and optimizations, and I'm like, just let me yield some values. Hey, look at that. We're generating some cool types. So nested has the type option of nested, which creates this one. And that's exactly what the schema has defined. So let me change ID and name because other types already here have ID and name. So this will be, let's call it identity, which will be, yeah, and name will not be a string. Let's make that an enum. Let's see if that works. So that's a string, but it's also an enum, by the way. So I think I'm pushing it. Not name, so this is nested. Let's call it, what do you call an enum here inside of nested enum? It's a bit bland, but okay. 1 or 2. So that's an enum from nested enum. If this works, then I'm happy. Ooh, did it just run? Okay. a pet nested, which has an identity optional. Why is the identity optional? Yeah, because it's not added to the required list. But now, because I've added it to the required list, but now let's see, pet nested identity int 64, nested enum has the type pet nested enum. Well, this name will get a bit silly after a while, but at least they are hopefully defined like they should. So this is order status, pet status, user role. I hope user role isn't defined twice. So this is pet nested enum. Yeah, user role is defined twice. Why is that? Because it was already inside of, yeah, it was detected inside of user and the property role, and it turned into user role, which already exists. Okay. So this might result in some kind of type collision, which I don't want to solve today. What would be an easy way to solve this? An easy way would be to keep track of the visited names and making sure that we're not defining anything from here. Rust is fun. I wouldn't say it's similar to F#. It's not. I heard a lot of people say it's very similar, at least in the sense of borrowing stuff and the type safety. I moved to it after playing with C++ and getting my fingers burnt. Oh, tell me about it. Understood the model used in Fabulous seemed to have been adopted by some degree. Well, somewhat. And the Fabulous hitting 101, I can playing with it again at some point. That'd be really cool. We'd love to see some stuff going on there. Maybe my CPU's laptop CPU is supported. Yeah, I could totally relate. Sometimes my computer is having so much trouble that it runs out of memory and it starts using the disk memory. So if I have a couple of Chrome tabs open, the more I add, maybe I have Teams open and I have GitHub open and YouTube open, for example, and I look at this and I already have like 20 megabytes over, and I have to go into my projects and start deleting a couple of node modules directories to get running again, or I should just close Chrome to get back on my feet. It gets really silly, so I think I need a new computer too. Maybe I'll look into it more. Yeah. Rust has the use, but the type safety and memory safety is all checked at compile time. Yeah, that's pretty cool. Could you pipe the output of botnet run into FSI to see if they moan about the code? What do you mean? Could you pipe the output of .NET run into FSC and see if they which output you mean? You mean the output in here for the compile time stuff. I think I can, but I'm not sure how to do it in this simple example. I don't think FSI accepts stdn either. Yeah, I don't think I could do it easily here. What I did with Snowflake before, let me look at it. So what I did with Snowflake, basically the same project. I'm not sure if you've heard of it. It's the same type of project, but instead of OpenAPI documents, we're using GraphQL schemas to generate the types and everything. So what I did is that the samples, I have a couple of samples here and a bunch of configuration files, and in the CI server, I just generate, or I could do it locally as well. In the build project, I basically I generate the entire F# project and build it to see if it compiles. Of course, I could go one step further to actually run the code that is generated, but I don't do that yet. For now, generating the types is the only thing that gets built. So what I do, I run .NET against the tool to generate a project, and once I have a project, I start running .NET build on each of the output directories. Like in here. Of course, this is a bit if-else statements just to make sure everything is working. It's a bit simplistic, but it works quite well. And this is running in the CI, so every time something wrong happens, it should tell me everything about. It should tell me if I have a compile error or something. So basically, it generates a bunch of projects and builds them. I want to do the same thing later on with Hawaii, but I'm not there yet. So yeah, we will see how that goes. Yeah, and Snowflake does have some kind of type resolution recovery. So I think I could look into how I did it before and implement it. For now, I'll implement it later. That sounds good for CI, but rather too much to do for a fast compile loop. Yeah, to be honest, I could just look at the things in here, and if they work, if they look like they will work, it's fine. I don't look a lot at the output really. Like I don't need to. I don't know, maybe that's just my way of writing code. I tend to spend more time thinking about what the code will do instead of actually like looking at it. Maybe because, I don't know, maybe if I have the option to look at the output every now and then, I will start doing random things in the code until it works, which I did a lot a long time. Like I do it a lot as well right now, but I don't do it as often because I get the idea, oh, I'll just do random stuff and until I see the output. I guess it is kind of the same. It's just a different way of writing of a workflow. Sounds good for CI. Yeah. In any case, let's see how we can fix the type collisions quickly. So I can do it here too, because enum. So we get the enum definitions. So we already know what the types will be, right? And I guess this list could also return what the type names will be. Or I could easily, well, not easily, but I could propagate a list of a mutable list, like a resize array of already existing type names, and try to resolve a new one if a collision happens. Okay, so this is already getting a bit useful. So that's really cool. Let's see, enum definitions. Let me get the enum type names. So let enum type names will be enum definitions list map first. Let me create a resize array visited types. A resize array of my starting from this, and I think I should give the visited types to this one. The visited types to this function. And this function, right? And then try to resolve the collision from there, and adding the types as well. Let me do that real quick. So visited types resize array of string. Of course, so visit, we just keep propagating it down the recursion. Alright, so just let's make sure that it compiles. Also for create type name, visited types will be a resize array. Let me just remove the use of the tuples just to get a consistent naming scheme. Okay, that's the values, and the visited types will be a resize array of string. Okay, so that works. Let me solve the compile errors. So this enum case and enum type name cases will be enum type name. Do it here, enum type name, cases, and the visited types, right? Why is it not happy? Visited types takes a resize array of string. That's correct, because I don't have it yet. So I need to define it first here. There you go. That makes the compiler happy. And finally, what do we need to do here? I missed something. Yeah, it must be this one. Type name, cases, and visited types. Okay, that I could look to solve the resolution from here. I might also need to propagate it to this function. Oh boy. Can get complicated quickly. Property name, record name, property name. Property name is just used for referencing here. Alright, so let's see. Let's add this one to the visited types. So once we've decided a name, we add it to the visited types. What else? Yeah, the new types are coming up when we encounter a nested type or when we encounter an enum, so that's here, right? And the enum name will also be added to the visited types. Create enum type from the visited types. Yeah, the name of the enum is all the way here. So we get a type name and we have the visited types, and we need to figure out what the next one will be. Okay, let me see how I did that before, because so I don't have to do this all over again. Go Codegen. Yeah, I did something like this. I have a name and a visited types. It doesn't contain anyone, just return it like this. Else, try find something that starts with it. Find next type name. Well, this could be even more sophisticated. I think this is the one I want. This looks nice. Let's put it up. The normalized name will just be capitalized. A simple normalization. Okay. And the next tick will also work. So find next type name, which happens when we create a nested type with the first one. So find next type name from the field name, which is this property. Object name, which will be the record name. What else? Selections. We don't have selections. Well, actually we do have selections are like the nested property names. Okay, let me just take them. Nested property names. Because if something has like ID, two properties that is called ID and name, the find next type name will create maybe a type called ID and name. Like the summation of the things that the object contains. It's really it really takes a lot of things in consideration. So it's the field, the record name, the selections will be the property names. So the property names will be property value, which is the schema of the nested object, of which I want the properties, of course. Wait, value is an OpenAPI schema, and that's where I want the properties. Should work, right? Yeah. And properties is a dictionary, so I want the key from that. So sequence, map, fun, pair, the pair, give me the key, and it wants a list of those, right? A list of strings are the selections. So sequence to list. Nested property names, which will be used in the record. And finally, visited types. Okay. Find next type name, add it. And this one is deterministic. It will always find a new type name. We do the same when we encounter an enum. At least we should. Where is it? So find enum types. We don't do anything. Should we add though? I don't know. Create enum type. I think it's here. Yeah, and enum doesn't have selections. Also doesn't have a parent name. Interesting stuff. It's getting late here. Thanks for streaming. Good night. Have a nice day. See you next time. So I'm already, so I guess this won't take into account the other, yeah, what I really wanted to do solve is the nested things from the enums. Well, I guess we could do that. Create enum type, where is it called? It is called here. Called here as well. Where else? Okay. I think only the nested enums should do type resolution, because the top level enums should not change the name. The type name of the top level enums should stay as is, but the enum definitions that are nested, which are created in here, should have those. Let's see how we are finding them, because we are finding them find enum types. Yeah, we are using a parent name, so we should probably just return that here as well. Parent name, enum value, cases. Okay. For parent name, enum case, if not empty, it probably won't be empty. No, I didn't want that. I don't think we need to return enum case. So okay, just return everything. Parent name, okay, I need to define the visited types even further above. Okay, so that's a resize array, which is of type string. All right. The enum definitions, their names will be enum name and cases. Their names will be find next enum type, where it takes the field name, which is the enum name, parent, selections are empty, and takes the current visited types. And those are my nested enum types. Okay. Well, I guess I should do it like this. Let next enum name equals find those things, parent name, enum type name, and created. Okay, that was quite something, because okay, now we have the nested definitions resolve the name collisions. I hope not having selections won't interfere with that. Selections being the nested types, the nested fields, but enums don't have fields, so there's that. Because I want user role to stay as is, and if there is a name collision, I want it to be resolved at the field level right here, right? But there could be a problem with that, because user role is made up from user and role, and maybe it doesn't know anything about the about the added types. All right, let's see. So far so good, I think. Okay, so user role was not modified. User role here. Okay, we have the. Okay, this is not good. This is just pets. I think I broke it, because this should be order status. This should be user role. Okay, pet nested enum. Okay, so the names are being resolved. Okay, let's just go back. And it has to do with the fact that visited type starts empty, but it should not start empty. It should start with parent name plus enum name. So for each one of those, visited types add parent name plus capitalize enum name. I think. Better try. Okay, user role. Nope. That is not it. Because what does find enum types do? Yeah, it already adds the parent. So maybe I shouldn't look into parent name from here. Go back. Visited type will be enum name. And just keep on propagating. Enum type name. Well, the parent is empty, but is that okay? I'm not sure. what does this do? If not visit object name. Okay, what happens if I just use enum type name instead without finding the next tick, because I don't think this works for enums. Let's see. Okay, role, user role, auto status, and user role again, which should not have happened. Should not have been outputted here. Why was it output there though? Let's see, was it because of... Okay, so I think we found it. Yeah, this one works. The pet status works. Oh, actually it doesn't. The pet nested. Yeah, because this should be pet nested. Let's look at it again. It's not an object and it's not a reference. Create the field, that works. However, you have the nested property names, record name, property key, nested object name. Okay, so I need to add object name as the very first, okay. Object name and field name. Or maybe I need to change this. Capitalize field name, so that it always takes the field name into account. Okay. Let's try that. Because I always wanted to take the object name and field name into account and not just the object name. Okay, pet nested works, that's cool, and it's also referenced in here, so that's this pet nested, and then we have pet nested enum, which is also correct. Almost. This 1 or 2 is called pet nested enum, but it should be pet nested enum, right? Yeah, it didn't take the right parent name, it took the parent. It took the grandparent instead. So we don't want the grandparent. Okay, we're getting somewhere. What about user role? Do we still have that problem? Yeah, we still have it. Because why did this happen actually? So yeah, only if it's here then created, but why was it found here below? Create schema. Key. Let's say is top level. Let's skip the top level ones. So find name, option of a string. Parent name is the type name, and then okay. Let's skip the top level ones. So match schema value with string enum. Some cases then skip, otherwise do this. So when you're trying to find the enum definitions, skip trying to find the top level definitions. Okay, let's give that a run. So many problems at once. Okay, user role is generated because it was a top level enum definition. Pet nested. Yeah, no, we do have a user again. All right. That is not very good. Let's see why. Let's see if it finds a user role here. Let me try to debug this for once. Yeah, it did find user role, but why? How did it find the user role? What is this one doing? So maybe we should say when the reference is not null. Not is null, because if it's referenced, then we have a problem. Schema reference. Because this should only find the inline enums, the inline ad hoc enums, and not the ones that can be referenced as a proper top level type. I think this is the problem, that I could get back into resolving the other ones. Let's see. Nope. It still finds it. Somehow. Not as null. Enum count and... Oh, it should be is null, so it should be a reference. If it's a reference should be null, because otherwise it's a reference type. That's what I mean. if I can get this maybe, and I can get the property names to, okay, auto status, pet status. Yes, so that's cool. We don't generate enums for top level enum types. We only generate enums for ad hoc enum types, which are generated somewhere in the schema, like in here, nested enum, which should take a name of pet nested enum. So let's see why the type has become pet nested enum and not the other one. So this is the type name. Let's see where this is called. It's called here for the top, for the found definitions, enum type name. Okay, enum type, enum cases. This one is interesting. I'm not sure about the visited types. I have this like an array that I'm passing through all these functions. It's I'm mutating everything. I'm not sure if this is the right way to do it. It's working okay-ish for now. Yeah, global types, enum types, and the top level stuff. Property name, record name required, property name. Let's take a look here, because I think what is, yeah, this one is correct. This one is correct here, I think. Record name plus capitalized record name. But the generated type is not. Why is that? Are we generating more stuff? It's just enum name and enum case, so it must be that. No, this is also good. Take a look at what the debugger says. So this is the parent name, and we found 1 and 2, but that's not the this is the enum name. Okay. Property name. Order status. Okay, what else? Let's look at the other cases. Parent name API response, enum name is no. Okay, not API response code. Figure ID, pet, okay, we're getting there. So we have pet and pet ID. Okay, pet nested. And we will look into, that's the enum name, pet nested. The parent name will be pet nested. And the schema will be, take a look, object, properties, identity, and nested enum. So somewhere this nested enum is being lost. Look at it. Property name, identity. We won't look here actually. But next time, enum name will be get identity, but it's not an enum, so it will go back here inside. We'll get into here again. And we won't generate anything, but now the property name will be okay, it's still nested, and now it should be nested enum. So we have enum name, okay, this is the property. What's the parent name? Still pet. I feel like the parent name should be updated to Alright, I think I'm going too much into this. I'm almost there. I think it's around this place, because I'm propagating the top level parent name all over down, but it should be updated as well. This is the parent name. The parent should change with the enum name. Yeah, I think I'll wrap it up for today. This has been quite the journey. I'm just making changes to the pet store, and it already becomes quite complicated just to get this one right. All right, let's for now I think I got the rest good, especially with respect to nested objects and top level enums and all that. We are not generating user role again, so that's good, but we're still generating pet nested enum, which is not the correct referenced type, because the correct reference type should be pet nested enum. So that's something to solve another one. For now, thanks a lot for joining. I hope you enjoyed this somewhat. It's always a challenge to do these live and try to make actually something out of them. That's why I'm doing them frequently, because I want to get into the project and make something productive every time, instead of just me looking at a debugger for hours. So and I think I did something I was somewhat productive today. So with that, I want to wrap it up. Thanks again for watching. Let me know what you thought, and have a good night.